Hello guys, I hope you guys are doing well. Okay, so today I'm going to study about linear differential equation with constant coefficients. Okay, and before going to the study of differential equations, linear differential equation with constant coefficient, I would love to introduce some basic notations like d upon dx is simply represented as d, okay, or y dx. D square y upon dx square may be represented by this symbol, okay, and d3 upon dx to the power 3 may be represented as d to the power 3 or y triple dash. Similarly, up to nth you can represent it as. And we have some properties of the derivatives also. D to the power n plus dm can be, associative, can be commute, okay. So similarly we have these properties, okay. Du plus v can be distributed as du plus dv, where u and v are the functions of x, okay. And d minus alpha, d minus beta can be interchanged with d minus beta and d minus alpha, where alpha and beta are the constants. Now d inverse u is d inverse can be written as integral sign, okay. D inverse means integral sign, okay, and u dx. So similarly d minus 2 means double integral of the function u. D minus n means n time integrals of u, okay. So these are some basic properties or basic notations before going to the study of the linear differential equation with constant coefficient. And we have these properties, okay. dd minus 1 equals to 1. So guys, I think you guys can understood this property and can memorize these properties very easily, okay. Now linear differential equation with constant coefficient. A linear differential equation with constant coefficient is that in which the dependent variable, okay, I should write with constant coefficient with constant coefficients is that in which the dependent variable and its derivative, the dependent variables and its derivatives occur only in the first degree. In the first degree, and are not multiplied together, and are not multiplied okay, are not multiplied together. One more thing, the coefficients are constants and the coefficients should be constant. Are constants. Like, for example, here we have dny upon dxn plus 4y is equals to 0, okay. Or we can have the another example as d square y upon dx square and plus 2 dy upon dx and plus 3 y is equals to e to the power x, which is the another example of the linear differential equation with constant coefficients. Okay, now guys, general form of a linear differential equation of the higher degree with constant coefficient can be written as dny upon dxn, okay, and plus a1 dn minus 1y divided by dxn minus 1, and then plus a2 dn minus 2 divide dn minus 2 derivative with respect to x y, and then plus dot 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 up to an y is equals to capital X. Okay, and you can see here where capital X is a function of x. Okay, where capital X is a function of x, and a1 a2 a3 and dot 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 up to n are constants. Okay, are constants. So which is a general representation of a linear differential equation with constant coefficients. Now guys, how we can write it as, you can write it as like dn plus a1 dn minus 1 and plus dot 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 per plus an y is outside is equals to x. Okay, and you can rewrite it as also f of d is equals to f of d y is equals to x. Where f of d, what about f of d? F of d is the simple representation dn plus a1 dn minus 1 and plus dot 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 plus up to n. Okay, it is your f of d. So we have this simple representation of the linear differential equation with constant coefficients. Okay, one more thing, we talk about the solution of linear differential equation with constant coefficients. Okay, so general solutions will be decided here for such type of differential equation, and in the first part we will find the complementary function. Okay, and in the second part we will find particular integral. Okay, particular integral. So means you can write it as in the abbreviation form. Complementary function means CF, particular integral means P dot I. And remember one thing, this CF will be due to of f of d, okay, and this pi will be due to of y, okay, will be due to of capital X. In case, you can write note here, in case if capital X is equals to 0, so your particular integral will be calculated as 0. Okay, and there is no need to find your particular integral, just general solution will be decided of the linear differential equation with constant coefficient by complementary functions. Okay, now question is that how do we decide complementary functions? Okay, so I'm writing here some working rules to find the complementary functions. Okay, working rule, and these are very important points. Okay, now number one, write your equations as, rewrite your equation as your given differential equation as dn, okay, plus a1 dn minus 1 and plus a2 dn minus 2 plus dot 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 plus an y is equals to x. First you will write your given differential equation as, and in the second step, to decide the complementary function, we will write the auxiliary equations. I'm writing here auxiliary equation. A into V as m to the power n plus a1 m to the power n minus 1 plus a2 m to the power n minus 2 and plus dot 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 plus an m to the power n minus 1, m to the power an and m to the power n minus 1, obviously it is 1, equals to 0. So it is your auxiliary equation, okay, and which is a first class polynomial in terms of n. Now by the theory of polynomial, it will have the different roots, okay. If we have the polynomial, obviously we know that in a polynomial we have the roots equals to we have the number of roots equals to its degree, okay, and there will be different roots. There will be the nature of the roots of this polynomial, and some roots are real, okay, and some roots are imaginary, okay, that is of the form alpha plus iota beta, and some roots may be surd, okay. Surd means of the form alpha plus square root of beta. So guys, remember one thing here, complementary functions will be decided on for the different natures of the roots of the auxiliary equations. So here we have the big task to find the roots. After that, to characterize their nature, and on the different nature of the roots to write the complementary functions, okay. So I'm writing here one point also noted here. If alpha plus iota beta is a root of the polynomial, then alpha minus iota beta should also be the root of that polynomial, because the complex roots, I'm writing here imaginary, and sorry, not imaginary, it is complex root, okay, complex root. So complex root always come with conjugate pair, okay. If alpha plus iota beta is a root of the equation, then alpha minus iota beta will also be the root. Similarly, the surd also come in the conjugate pairs. If alpha plus square root beta is the root of the polynomial, then alpha minus square root beta is also the root of that polynomial. Now, for these nature of the roots, we have the different complementary functions. So what about the case 1? In the case 1, okay, I would love to study this in the form of the table, okay. So case number first, if all the roots are real and unequal, what does it mean? That is, if we have the roots, if m1, m2, m3 and dot 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 up to mn are the roots, and these roots are unequal and are real, then the complementary functions will be decided by CF is equals to C1 e to the power m1x and plus C2 e to the power m2x and plus dot 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 plus Cn e to the power mnx, right? And in this case, if two roots are equal, Okay, what do you mean by the two roots are equal? That is uh, m1 is equals to m2 and rest are different. Okay, rest are different. Then how will we decide complementary function? Then the complementary function will be decided as, for these equal two roots, we write here first c1 plus c2x and e to the power m1x, okay, and then plus c3 e to the power m3x, and then plus dot 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 cn e to the power mnx, okay. So it is the complementary function for this due to this, and it is due to this. Now in case if three roots, if guys, if three roots are equal, okay, if three roots are equal, that is m1 is equals to m2 and is equals to m3, and but are not equals to m4, equals is not equals to m5 and dot 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 up to mn, right? Then how we will decide the complementary function? So complementary function will be decided as, c1 plus c2 x and plus c3 x square e to the power m1x and plus c4 e to the power m4x, and then plus dot 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 up to cn e to the power mnx. Okay, it is your complementary functions. Okay, and now for example, you can say also, if we have the roots as 1, 2 and 3, so your complementary function will be as cf is equals to c1 e to the power x and then plus c2 e to the power 2x and then plus c3. So if we have the roots 1, 2, 3, then we have the complementary function as c1 e to the power x, c2 e to the power 2x and c3 to the power 3x. For the support of this property, if we have the roots like 1 comma 1, 1 comma 1 and comma 2 and 3, then what about the complementary functions? Then cf should be c1 plus c2x e to the power x and then plus c3 e to the power 2x and then plus c4 e to the power 3x. Okay, so in case if the three roots are equal, like 3 or 3, you may take the different value 4 comma 4 comma 4, 2 comma 3. Okay, for example, you have the 5 roots and 3 roots are identical and 2 roots are different. So what about the complementary functions? So complementary function will be decided as c1 plus c2x plus c3 x square and e to the power 4x, okay, and then plus c4 e to the power 2x and then plus c5 e to the power 3x. So one more point to be noted here. You can write here c4 e to the power 3x and c5 e to the power 2x also. So there is no conflict of interest here. Okay, so what about the case 2? Case 2, in the case 2, if the roots are complex, if the complex roots are there, complex roots are there, okay, complex roots are there means that is we have alpha plus minus iota beta. Okay, so since the complex root always comes in the conjugate pair, so we will always have the two roots here for the auxiliary equation. So how will we decide complementary function? So complementary function will be decided as e to the power alpha x, okay, and c1 cos beta x and plus c2 sin beta x, okay. Now if two complex roots are repeated, if two complex two pair of complex roots are repeated, okay, then what about that? What about the complementary functions? Then the complementary function will be decided as e to the power alpha x and c1 plus c2x cos beta x, okay, and then plus c3 plus c4x, okay, sin beta x, okay. Now in case number 3, if the roots are surd, okay, if the roots are surd, and surd roots always come with conjugate pair, then the complementary function will be decided as e to the power alpha x, and surd means alpha plus minus square root beta, okay, e to the power alpha x and then c1 cos hyperbolic square root beta x and then plus c2 sin hyperbolic square root of beta x. If these two surds root are repeated, if two surds roots are repeated, what about in that case? Then the complementary functions will be decided by e to the power alpha x, okay, and c1 plus c2 x cos hyperbolic square root beta x and then plus c3 plus c4x and sin hyperbolic square root beta x. So we can decide the complementary function with this theory. Now we will solve the question based on this theory. Come on. Now we solve the question. Come on. And the question is that solve d square y d to the power 3 y upon dx to the power 3 and then plus 6 times d square y upon dx square and then plus 11 times dy upon dx plus 6y is equals to 0. Okay. Now we need to solve it. Okay. So solution is that the given differential equation is d to the power 3 plus 6d square plus 11d and then plus 6y is equals to 1. Remember one thing, here we are getting capital X is equals to 0, so our particular integral will be decided as 0. So for the general solution there is no need to find the particular integral. We will just discuss the CF. So for the CF we need to find the roots of this. So to find the roots we will write first its auxiliary equation, that is m to the power 3 plus 6m square and then plus 11m and then plus 6 is equals to 0. Remember one thing, to find the roots of this, here we require the theory of the polynomials or theory of the functions, okay, theory of the roots of the functions. So first root we will decide by hit and trial roots. For example, we have all the sign are positive here, so our negative roots will be there. Okay, so put here m is equals to -1. So after putting here m equals to minus 1, you will find minus 1 to the power 3 and then plus 6 into minus 1 square and then plus 11 into minus 1 then plus 6 equals to 0. I think it is 0 minus 1 and plus 6, it is minus 11 and then plus 6. Okay, so it is obviously 0 because minus 12 and plus 12 equals to 0. So minus 1 is a root and this implies that m plus 1 is a factor of this polynomial. Okay, so if it is the factor, then on dividing if we divide by m plus 1 with this factor, so we should get the remainder as 0. So m to the power 3 6m square plus 11m plus cx, if we divide it by m plus 1, then remainder should be 0. Now we check m to the power 3 plus m square. On subtracting these two cancelled out, we have here 5m square plus 11m. Now multiply by 5m here, so it is 5m square plus 5m. Okay, then minus cancelled out, so it is 6m. Okay, so we have here plus 6. Okay, now multiply by 6 here, so you will get 6m plus 6. Okay, then minus it is cancelled out and we have the remainder here 0. So what about this polynomial, that is m to the power 3 plus 6m square plus 11m and plus 6 is equals to, it can be written as m plus 1 into m square plus 5m and plus 6. Okay, now we need to find the two roots from this factor. Okay, so now what about the roots of m square plus 11m plus 6? I am calculating here m square plus 11m plus 6. M square, I think it is 5m. Okay, m square 5m plus 6 equals to 0. So we can middle term split here. Okay, 3 plus 2 m and plus 6 is equals to 0. So m square plus 3m plus 2m plus 6 equals to 0. So m common, m plus 3. Okay, and then plus 2 common from here, you will get m plus 3 is equals to 0. So m plus 3 you can take common and find m plus 2 is equals to 0. So you have here two value for m equals to minus 3, m equals to minus 2. So we have the roots as m is equals to minus 1, minus 2 and minus 3. Obviously all these three roots are unequal, okay, and real. Therefore the complementary function will be decided by c1 e to the power minus x and then plus c2 e to the power minus 2x and then plus c3 e to the power minus 3x, which is the required answer, and which will be treated as the general solution also. Why? Because the complementary function will be decided at 0 here. Okay, so you have just simple theory to find the solution of the linear differential equation with constant coefficient. Now we deal another example in support to theory, and the example is d to the power 4 and d to the power 4 minus 5d square plus 4y equals to 0. Now we need to solve this. Okay, now come on, what about the solution? So for the solution we have given differential equation is d to the power 4 minus 5d square plus 4 equals to 0. Now what about the auxiliary equation? Auxiliary equation is m to the power 4 minus 5m square plus 4 is equals to 0. And sometimes you can consider it as right m square is equals to t. Okay, so you can find here mt square minus 5t plus 4 is equals to 0. Now come on, solve it. Okay, and you will get 2 factor here, t square minus 4 plus 1 5. Okay, t plus 4 is equals to 0. Then t square minus 4t minus t plus 4 is equals to 0. So take t common, t minus 4, then minus 1 common, t minus 4 is equals to 0. Then you will get t minus 4 and t minus 1 equals to 0. So here you have m to the power m square minus 4 because the t is m square, and t square m square minus 1. So you can further solve it, write m square minus 2 square, right, or m square minus 1 square. So you can apply here the formula a square minus b square. You can write m minus 2, m plus 2, or m minus 1, m plus 1, and then you can find the roots. So we have the 4 roots here for m, that is 1 and minus 1, 2 and minus 2. All the roots are real and distinct. Therefore the complementary functions will be decided by c1 e to the power x plus c2 e to the power minus x plus c3 e to the power 2x and then plus c4 e to the power minus 2x. Okay, and the particular integral in this question will also be decided at 0 because the capital X is 0 here. Okay, next question we can deal here in continuation is solve d to the power 3 minus 3d square and then plus 2d, okay, y is equals to 0. Now we need to solve it. Okay, for the solution of this differential equation we will follow the same and parallel steps. Okay, now given differential equation is d to the power 3 minus 3d square and then plus 2d is equals to 0. So take d common, so it will be d square minus 3d and then plus 2 is equals to 0. So now d, what about the solution of this? D square minus 2d, you can take 2 plus 1d plus 2 is equals to 0. So d and d square minus 2d minus d plus 2 is equals to 0. Okay, so d, now come on, take d as a common, so it is d minus 2, and take minus 1 as a common, it is d minus 2. Okay, so obviously we have the 3 roots here, d and it is d minus 2 and d minus 1 equals to 0. So we can solve it in terms of d also. Okay, here we have solved it in terms of n considering d as a m. Here we can solve it in terms of d directly. It is the right way also. So d equals to 0, 2 and 1. These are the 3 roots of this differential equation. So you can decide the complementary function as all these 3 roots are equal. Remember one thing. So c1 e to the power 0x plus c2 e to the power 1 into x plus c3 e to the power 2 into x. So finally you can write it as c1, because e to the power 0 the value is 1, c2 e to the power x and plus c3 e to the power 2x, which is the required answer. Okay, so guys, we have the simple questions to understand this theory. Okay, next I would love to discuss the another question also, and the question is solve d square minus 2d and d square minus 2d plus 5 whole square y is equals to 0. Now in support to the solution we can write here given differential equation, okay, which is d square and minus 2d and plus 5 to the whole square y is equals to 0. What about the auxiliary equation? Auxiliary equation is m square minus 2m plus 5 is equals to 0. So now come on, decide the root. So we can write m square minus 2 can be written as, I think it cannot be factorized obviously directly. So we can factorize it as with the help of Sridharacharya. So we can apply here minus b, okay, minus b, because the value of a is 1 and the value of b is minus 2 and the value of c is 5. On comparing a m square plus 2m plus bm plus c is equals to 0, which is a quadratic equation. Okay, so minus b plus minus square root b square means 4 minus 4, a value of a is 1 and the value of c is 5, and then divided by 2 into 1. Okay, we have the Sridharacharya rule as m equals to minus b plus minus square root b square minus 4ac divided by 2a. You can apply it directly in each and every quadratic equation to find the two roots. Okay, in each, okay, in each or every differential, every polynomial, quadratic polynomial, and you can find the two different roots. So it is 2 and plus minus square root of 4 minus 20, then divided by 2. So you can write here 2 plus minus square root of minus 16, then divided by 2, and you can write it as 4 minus 16. So 4 minus 16, so it will be 2 plus minus 4 iota, okay, divided by 2, and the root will be 1 plus minus 2 iota. Okay, so the two roots are here. So this implies that m minus 1 plus 2 iota, okay, is a root of this, and m plus 1 plus 2 iota is the another root of this. Okay, so we have the two roots here, and these two roots are repeated obviously due to the power of this. So we have the four roots, 1 plus 2 iota, one of the roots, 1 plus 2 iota is also one of the roots, and 1 minus 1 minus 2 iota, and minus 1 and minus 2 iota is the another. I think not, let me check it out. Come on, one root is 1 plus 2 iota and another root is 1 minus 2 iota. Okay, so we can write here m minus 1, so it will be written as m minus 1 and 1 minus 2 iota. Okay, so we have plus minus 2 iota and plus 1 minus 2 iota. So we have these four roots. So obviously we can find the complementary function with the help of theory of the complementary functions, as we have two repeated roots, two complex repeated roots. So you can write e to the power alpha means 1 into x and c1, okay, for these two roots, because these two roots are repeated. Okay, and c1 plus c2x, no, because we are getting these two roots and it is the biquadratic, so we should have the four roots, and it is due to this we will have the two root. Okay, and due to this we have the two roots. So we can write simply, here, let me check it out. Come on, it will be we have here actually two roots of 2 degrees. Okay, 1 plus 2 iota and 1 minus 2 iota. and it is c1. Okay, c1 plus c2x and cos 2x, c3 plus c4x and sin 2x. Okay, so you can apply this theory as, and we have the number of questions to apply this theory. Okay, so in the next lecture we will discuss some other problem also based on the same theory. So I hope you guys can understood, and I request everyone to suggest, comment, share, like. Okay, thank you everyone, see you in the next class.